Hey guys, I'm going to be going through the topic of normal distribution, specifically question 17 of the Maths CSSA 2024 trial paper, as it's something that advanced students tend to go over quite quickly at the end of the year, and sometimes some quite complex questions can pop up. So with question 17, we have the weight of boxes of cereal that are produced are normally distributed with a mean of 650 grams and a standard deviation of 5 grams. Boxes of cereal are fit for sale if they weigh more than 640 grams. And we're also told that if the factory produces 1 million boxes, how many would you expect to be fit for sale? So straight away here, I can see by the wording of this question that since it says it's normally distributed, we are going to be working with normal distribution, and therefore we're going to be working with that bell curve that we see in our formula sheet. So it's always good with these kind of questions to kind of list out the key information that they tell us. So they've told us that they have a mean of 650 grams. We're also told that it has a standard deviation of 5 grams. And we know that we want the boxes of cereal to weigh more than 640 grams. So this is going to be your X amount here, or your desired amount. So our desired amount we want to be greater than or equal to 640 grams. So since we said it was related to that bell curve that's in our formula sheet, our bell curve is linked to our Z-scores. So we want to find a way that we can turn our X values into our Z-scores, and we're going to be doing that by using the Z-score formula. So we have Z is equal to X minus our mean over our standard deviation. So therefore our Z-score for this particular outcome is going to be 640 minus 650 over 5. Which is going to give us a standard Z-score of -2. So let's see where -2 sits on our bell curve. So redrawing the bell curve that's in the formula sheet, we have it symmetrical around 0. We have the points -2 and 2, like that. Okay, so what we know here is that if Z is equal to -2, and we know that we want X to be greater than or equal to 640, because these are correlated here, we can say that we actually want Z to be equal to 600 and greater than or equal to 600. Z is going to be greater than or equal to -2. So if we're looking for when Z is greater than or equal to -2, in my diagram here, we're looking specifically for this percentage. So we're going to work with our formula sheet to see how we can get that percentage. On our formula sheet, or what we know from statistics, is that anything on either side of our mean is going to be 50%. So this part here is going to represent 50% of our data. But we still have this part here between Z-score of -2 to 0 that's still unaccounted for. Well, we know that in our formula sheet, from -2 to 2, that's where 95% of our scores sit. So therefore, if we only want to look at from the scores between 0 to -2, what would we be doing is going 95 divided by 2, which is going to give me 47.5%. So therefore, if 47.5% of scores lay between 0 and -2, therefore between -2 and greater than or equal to -2, I'm going to have Z greater than or equal to -2 is going to equal to 50% plus 47.5%. So 50% plus 47.5% is going to give me 97.5%. So therefore you can expect 97.5% of boxes of cereal to be fit for sale. Now this question that's not all this question is asking us. In this last little part here, it says we need to find how many would be expected to fit for sale if the factory produces 1 million boxes. So all we have to do to wrap up this question is to find what 97.5% is of 1 million. So we would go expected value is equal to 1 million times 97.5%. And therefore you get 975,000 boxes of cereal that you would expect to be fit for sale. Okay, so hopefully that helps. That's how you'd answer that particular question. It's all about kind of identifying what the main pieces of information are and then relating it back to the bell curve that you see on your formula sheet.